Let's look at the difference quotient. And of course, this is for the derivative of f of x at a. So f prime of a, that's what this is. And what I want to look at now is, under what conditions would this not exist? In other words, is there any values for a, any x values for a, that would make a function not have a derivative at that point? In other words, when does f prime of a not exist? Well, you can see here the difference quotient requires f of a to exist, right? Because you have to be able to say f of a. See, here's f of a plus h minus f of a. So if you have a situation where you have a lack of continuity at a point, so you have a discontinuity, like let's suppose we have a graph that looks like this, and here's a. Okay. Well, the derivative wouldn't exist there, because for a derivative to exist, continuity is necessary. Now, it's not sufficient. Continuity is not enough, but it is necessary. Now, let's look at another situation where the derivative would not exist. Now, remember, when we talk about a derivative, we're talking about a slope of a tangent. So let's look at this curve, a curve like this. Now, right here at A, let's suppose right here we have a vertical tangent. Now, remember from Algebra 1, when you first studied finding slopes of tangents, or when you first studied finding slopes of lines, you found that vertical lines have an undefined slope, right? Because you end up trying to divide by 0, because the x's are the same. So this is another situation. If you have a curve where the tangent happens to be vertical, the derivative is not going to exist there. It's just not. Now, let's look at another situation. Let's suppose that we have, let me give myself some room here. Let's suppose that we have this nice curve coming up like this. And, of course, here is A. And then we have it coming down like this, and the curve continuing like this. Notice it looks like if you've got, if you think of a secant line coming up through here and you're trying to get a tangent coming from this direction over here, it's going to be different than if you have a secant line over here trying to get a tangent coming from this direction. In other words, you've got a sharp point here, and this line to the left and the line to the right are not going to be the same. So what happens is, whenever you have a sharp point like that, that tells us that you're not going to have a derivative at that point. So for example, maybe we have, something like this. There's a real distinct one there. Notice that the slope of this line is completely different from the slope of this one. So it may be the opposite, right? And let me draw another one here. Okay, so there's another one. And we'll say these are all at A. So these are all examples where you have sharp points. So when you talk about does the derivative exist, well, it's not going to exist at discontinuities. It's not going to exist at vertical tangents. And it's not going to exist at these sharps, corners, these sharp points in the graph. Now, if you don't always have to look at the graph. Sometimes you'll just look at it algebraically. Let's suppose we have x to the 1/3, and we want to find the derivative. Now, this x to the 1/3, its domain is all real numbers. But let's look at the derivative. The derivative of this function is 1/3 x to the negative 1/3. And x to the 1/3, negative 2/3. I'm sorry, negative 2/3. Right? Just using the power rule. Sorry about that. Now, obviously, this function, if if we put this in the bottom, this is just going to be 1 over 3x to the 2/3. Now, obviously, this function is not defined at x equals 0. The derivative doesn't exist there. Now, notice the function itself, yeah, it's fine. You put in a 0, that's cool. But the derivative doesn't exist at x equals 0. Now, let's look at the graph and see if we can figure out why. What's going on at this x equals 0? Okay, so I've put this function in Desmos, the cube root of x, which is what we differentiated. And you can see here, it looks like at 0, there's a vertical tangent. And remember, that was one of our conditions where we said, okay, the derivative's not going to exist there. So there is what that would look like.